this video is on solving the Chinese remainder theorem. So the way the Chinese remainder theorem works, I'm going to say given P and R, okay, so given P and R, okay, as co-prime, these are co-prime, and I'll explain what co-prime means. So I got P and R. So if, okay, so it's going to say if X congruent to, basically that's going to be Y mod P, see that? So Y mod P, and Y, so that's, and X is equal, so X is congruent to Y mod R, then X is actually congruent to Y mod P and R, okay? So this is what I'm trying to solve. Now, what is, so if you say X is congruent to Y mod P and Y is congruent to Y mod R, therefore X would be congruent to Y mod PR. Now, I want to discuss co-prime. What do we mean by co-prime? The co-prime, if you take the GCD of two numbers, the result is 1. So for instance, if I take two numbers, 12 and I'm taking 25, what are the factors? This is 2 and 6. So, and then 6 would be 2 and 3. So the factors of 6 here, the factors of 6, it's actually, factors of 6 is going to be 2 second to the third. Now, how about the factors of 25? 25, the factors are 5 and 5. So if you look at 25, the factors are, so there are no common factors. So that's why these are co-prime. So if I take the GCD of 12 and 25, I end up with 1. So therefore, they are co-prime. So how about if I give you another example? So let's pick another problem. How about if we take 12 and say 15, okay? What are the factors? So 2 and 6, and this would be 2 and 3. So the factors for 12 is going to be 2 squared and 3. How about the factors of 15? It's 3 and 5. So 15 is actually 3 and 5. So if you look back here, 3 and 5, so I'm looking at the factors for 12, which is 2 squared 3. Factors of 15 is 3 and 5, so I got a common factor. So the GCD of 12 and 15 is actually 3. So this is not co-prime. So these 15 and 12 are not co-prime because their GCD is not 1. So let's go ahead and actually do a problem. So I'm going to rewrite this. Okay, they have to be co-prime. So I want to solve. So this is solving linear congruency. Okay, using the Chinese remainder theorem. How does that work? So I'm going to give you some terms here. There would be, so let me write this down. So I'm going to give you, so let's say X here is congruent to 1 mod 3. We're trying to solve for X using congruency. X congruent to 1 mod let me pick 4 here, 4, I go up the ladder, 1, so x, that would be 1 mod 5, and then x would be 0 mod 7. Okay, so let's solve for x. How do we end up solving for x? Now my point becomes, I need to create big M, and big M is 3 times 4, see 3 times 4 times 5 times 7. 3 times 4 times 5 times 7. I end up getting 420. Okay, 420. Now, I need to create the little m. So m sub 1, m sub I. So if m sub 1, I'm going to use these 3 terms in different combination, different arrangement. So how about if I pick 4, 5, and 7. If I take 4 times 5 times 7. So this, for M1, I end up getting 140 Y1. So this is 140 Y1. Okay, so it's 140 Y1. Now for M sub 2, so maybe I should just leave out so I left out, okay, so I left out the 3 in the first term. In the second term, I'm going to leave out the 4, so it will be 3 times 5 times 7. So this gives me 105 Y2, okay? Now, and the third, so m sub 3, now it's going to be, what should m sub 3? Let's do 3, 4, and 7. So if I do 3, 4, and 7. So 3, 4, and 7 gives me 84 y sub 3. Now, how about m sub 4? So m sub 4, 3, 4, and 5. 3, 4, and 5. Okay, so I took different arrangement, different combinations, so that gives me 60 y sub 4. Now, coming back to this, so this is where I got my numbers. So what I'm going to have to do, instead of x here, I'm not going to erase anything, I'm just going to leave, so x. So look what happens. So instead of, say, x, what I'm going to plug in m1. So this is m1, and m1, in this case, 140 y1. See that? So this is, okay, so m1 is 140 y1. See, that's congruency. Then I'm going to take m2, which is going to be 105 y sub 2, and so I'm only plugging in for x there. Now m3 is going to be, m3 is now 84 y sub 3. You see that? And then m4 is actually 60 y sub 4, and that's what I end up. So now all I have to do is actually solve. Now I have to clear this side here since you got it, since it's recorded. Now if I take this one, I'm going to go here. If I take 104 and I mod it, I use the modulus by 3, that gives me 2y1. And 2y1 is going to be, so if I take 2y1, so that would be 1 mod 3. Okay? And this ends up with 2. So it ends up as y1 equals 2. So in my case, y sub 1 is equal to 2. So this is my first result there. Then continue here. This would be 105 mod 4. So 105 mod 4 is going to be 1 y sub 2 congruency 1 mod, and that would be 4. And in this case, y sub 2 is going to be equal to 1 if I do the modulus. 105 and 4, so that gives me, so this actually gives me y2 is 1. Then I'm going to have 84 modulus 5, 84 modulus 5, which gives me 4, y sub 3 equals congruency to 1 mod, and that's a 5. So y sub 3 is actually, the result for that is 4. See how I'm going through this. Now, this one here is going to be 60. So if I do 60 mod 3, which gives me 4. So this would be 4 y sub 3, which is actually 1 mod, and that's a 7. So in this case, y sub 4 is going to be 2. Okay, so now I got my values. I get y1, y2, y3, and y4. All I have to do now, come up with the value of x. So the value of x is going to be, I'm going to take 1 times 140. See that? Times y1, which is 2, plus, I'm going to do 1 times 105. 105 times y1, which is 1, okay? That's the one there. So then I have, for ym3 would be 1 times, what is that? 84 times, okay, what is that? 4 plus, and now this is going to be 0 times, and what is it? 60 times 2. So now all I have to do is try to evaluate this. So 140 times 2 is actually 280. 280. Okay? 105 times 1 is 105. 84 times 2 is times 4, 16. So that would be 3, I believe 336. So that is 336. And this is 0 times, so that's a 0. So I can put there plus 0. If I end up adding 280, 107, and 336, it comes out to be 301. And this is the value of x. I mean, we could use different values. I could use, as long as they co-prime, I could have used 7, 11, okay, and I could take other numbers, but they have to be co-prime, and that's why I selected these ones. And this is how we solve for x, okay, solving linear congruency using the Chinese remainder theorem. And thank you for watching.